Hi, this is a course on feature engineering, and today we are going to look at custom binning. So basically, we are going to look at how do we transform a continuous numerical variable into custom bins. Okay, so in the previous video, we have looked at fixed binning method. Today we will be looking at custom bin width method. Now, in my experience, this is the more often the case as compared to the fixed bin width. Okay. All right, let's generate some data. So here we have some customer data, and we also have some customer range. The age varies between 0 to 100, and we have generated 10,000 customers data, right? All right. Now again, we might be building a model to predict how likely somebody to get a disease, or how likely somebody to buy a product, or something similar, right? Something which can be based on the age. But let's say it does not depend on the exact age, but on the age group they belongs to. So in such a scenario, rather than using the raw age as it is, we might bin it into custom bins. For example, here all the customers are the persons between 0 to 3. We are grouping them as toddler. Between 3 to 12, that's as child. And then similarly between 60 to 100, we are grouping them as seniors. Okay, so now again we can use the cut function from the pandas. So here we are providing the raw feature, and then explicitly the bin ranges. As we saw in the previous video, this will give us the boundaries, the bin boundaries. Okay, so this value age bin custom range, this will return the boundaries. For example, the first customer with age 61, the customer belongs to the bin with boundaries 60 to 100. This one we define here. And similarly, maybe this customer with age belongs to this 3 to 12. So that's the 3 to 12. So that's using the cut function without explicitly providing the labels. Now we can, if we call the same function with the label names such as defined here, then it will return the labels in the form of these strings. Okay, then as you know, in machine learning we don't work with the strings. Now we can convert these strings into the integers. We can either do one-hot encoding, or we can convert them into integers, because there is some order to it, right? For example, child are older than toddler, teens are older than a child, so on and so forth. So these are called ordinal categorical variables. So they have some order to it as well. So either you can convert them to integers like this, or you can use them as one-hearted encoded variables in the model. Okay. Now this is the raw data. So this is some 10,000 customers data, the ages we have, and here we are looking at the histogram. Now we have transformed this data into these 5 groups: adults, seniors, child, teen, and toddler. Okay. Now the other example, here we have again some customers data with their income, right? So we have their income. Now this income is between the range 20,000 to 250,000. Okay, and again we are trying to let's say build a predictive model where the customer likely to buy a product, or maybe the customer how likely they get some loan, etc. Right? For such scenarios, rather than the absolute income, the income group might make the model job more easier. Now, one of the other reasons why we might transform these continuous numerical variables into few bins is the interpretation becomes easier, because when we explain the results or interpret the model, it becomes easier to say when the customer income is high, these are the chances of them getting the loan. When the customer income is in the medium range, these are the chances of getting them the loan, right? So rather than working with these fixed numbers, we can convert them into some categories, which makes the model interpretation as well as learning easier. Okay. So again, we are using the same cut function from the pandas. So here we are providing the raw variable and without labels. Okay, we are simply providing the bin ranges, and these are the custom values because the space between them is not uniform. So this will return the ranges. Now this is just for our explanation purpose, so that we can see this value actually fall into these two values and so on. Similarly, this value falls into these values, so on and so forth, right? But we actually convert them into some categories. So here we are providing the bin names as well. So we can see the customer's income has been transformed into these labels like low, medium, high, and very high. Okay. Again, as before, because there is order to this variable, we can treat them as ordinal categorical variables, meaning we can either one-hot encode them, or we can transform them directly to integers. So higher the integer, higher the likelihood of getting the loan, etc. Okay. Again, we are just looking at the raw data as well as the transform data here. Here we have the raw data. As we know, as the income increases, the number of people with that income reduces, right? So there will be only few people with very high income, whereas in this group there are a lot more people. So we have transformed this into these four categories. So there are many people in this low income group. There are very few people in this high income group. Okay. Yeah. So those are the scenarios where we can transform a continuous variable into a categorical variable with fixed or custom bin width for various reasons, such as making the model interpretation easier. Sometimes the exact value might not be important. So maybe the group is important. So in such scenarios, we might apply such transformation. That's all for today. Thank you very much.